Let's talk about how to use synthetic division to evaluate a function at a given value together. And in order to get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. For this first example, we have f of x is equal to this x cubed minus 9x squared plus 21x minus 13. I'm going to go ahead and rewrite that function. So while this is our function, we're supposed to go ahead and evaluate it when x is equal to 3. All that really means is that we're going to go ahead and change each of these x's into 3's. So here's that same function. And then if we go ahead and swap out all those x's, for 3, we can essentially go ahead and evaluate this function when x is equal to 3. And then if we take this 3 and square it and multiply it by 9, that's going to be 81. So we're going to go ahead and take away 81. Then for this third term, 21 times 3 is going to be 63. So we're going to add 63 here. And then finally for this last term, let's go ahead and just take away 13. Now if we go ahead and combine all these constants, we end up with negative 4. All that really means is that when x is equal to 3, this whole function is going to be equal to negative 4. So if we were looking at this function, we would know that a point on this graph or on this polynomial function is going to be 3 comma negative 4. This would be a point along the graph. All right, so that method right there takes a little bit of work, right? So there must be a better way, and we can use synthetic division to do this a little bit quicker. And so to use synthetic division, we take the value that we want for x, which is going to be 3. We can go ahead and put that on this top left corner. I'm going to go ahead and put a box to kind of separate it out. And then we just take each of our coefficients. So we have a coefficient of 1 in the beginning, then a negative 9, then a positive 21, and we have a constant of negative 13. So let's go ahead and write those down. I'm going to say we have a 1 here, then a negative 9, then a positive 21, and then a negative 13. All right, so this is us just going ahead and setting up our synthetic division. Next, we're going to just go ahead and draw a line across here. First thing we're going to do is just bring this first number straight down. So the 1 is just going to come straight down. Then you're going to take this 3 on the side, multiply it by this 1, and that's going to be 3. We're going to put that right underneath this negative 9. Next, what we're going to do is just go ahead and add this column together. So negative 9 plus 3, that's going to equal negative 6. All right, now I'm going to repeat the process here. So this 3 multiplied by negative 6 is going to be negative 18. Let's put that underneath this 21. And let's go ahead and add this column here. So 21 plus negative 18 is really just 21 minus 18. So that's going to be 3. And then finally, just one more time, 3 multiplied by this 3, that's going to equal 9. Let's go ahead and add this column one more time. And this negative 13 plus the 9, that's going to equal negative 4. All right, so this number right here of negative 4, hopefully you can see is going to match what we had earlier. So this negative 4 matches this negative 4. So basically this last number in our synthetic division on the bottom right is going to let us know what the function's equal to when x is equal to this 3. So putting this all together, when x is equal to 3, f of x, or this polynomial, is going to equal negative 4. For number 2, we have this function f of x is equal to negative 3x cubed minus 8x squared minus 2x plus 16, and we're going to go ahead and evaluate this when x is equal to negative 2. All right, let's start by going ahead and just copying down the function. And while we have this function, we're going to go ahead and evaluate it when x is equal to negative 2. So if we go ahead and take this function, and let's go ahead and replace all these x's with negative 2, we can go and evaluate this the long way. So starting with this first term, negative 2 cubed is going to be negative 8. Negative 8 times negative 3 is going to be a positive 24. For this next term here, we have negative 2 squared, which is positive 4, times a negative 8 is going to be negative 32. So we have minus 32 for the second term. For this third term, we have a negative 2 times a negative 2, which is a positive 4. And this last term, we just have this plus 16. So we can just go ahead and copy that down and write plus 16 here. Combining all those constants together, we're going to get the number 12. So when x is equal to negative 2, then we know f of negative 2, or the value of y, is going to be 12. So if we were to plot this on a graph, we know that at negative 2, we're going to have the value 12 for the y value. So this point would be on this graph or on this polynomial function. All right, so while that's the long way again, we don't really want to have to do that. So again, if you just kind of get confused or stuck, you can always do that, and that's really what we're doing. The synthetic division is just a shortcut for it. It's a little bit quicker. Now, if you want to go ahead and try it on your own, go ahead and pause the video right now and see if you can replicate what we did earlier on the left side for that first example, but I'm going to go ahead and give it a go now. So I'm going to take this negative 2 and put it up on the top left corner, because that's what x is equal to for this example. Then I'm going to take the coefficients of negative 3, negative 8, negative 2, and this constant of 16, put them across the top. So we have negative 3, we have -8, -2, and 16. Let's go ahead and leave some space and then just draw a line going across here. All right, first thing we're gonna do is bring this -3 straight down. So we have this -3. Then we're gonna take the -2 on the side and multiply it by -3. That's gonna equal +6. We're gonna put that underneath this -8. Let's go ahead and add this column. So -8 plus 6 is gonna be -2. All right, let's repeat the process here. Take the -2 on the side, multiply by -2 here. That's gonna be +4. Put that underneath the -2, and let's go ahead and add this column. -2 plus 4 is going to be a 2. So that's gonna be that sum there. And let's go ahead and do one more time. -2 times 2 is going to be a -4. Let's go ahead and add this column here. So 16 plus -4, which is really just 16 minus 4, that's going to equal 12 here. So that's going to be what we call our remainder, or the value of the function, given that x is equal to -2. Putting this all together, when x is equal to -2 for this polynomial function, f of x, or the y value, is going to equal 12. All right, so there you have two examples of evaluating a polynomial function at a given x value, where I went ahead and showed you how you could do it the long way, where you just substitute and evaluate it, or we can also go ahead and do this using synthetic division, which hopefully you can see is a little bit quicker. If you found the video helpful, please consider giving it a thumbs up and sharing it with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.